Look at this question. There are some trigonometric identity. These are trigonometric identity. We will be using this trigonometric identities in our question whenever there is a requirement of this. Then, so look at this. Understand this question, and here I will tell you about this. What is it? This is formula, nothing else. This is just a formula. Now here remember sine minus x. If a theta is a minus in minus, then it will be as minus sine x. It is telling that it can be written as minus sine x, and this can here this negative sign will become positive if there is a cos function there. Cos minus x will become cos x. Okay. These are trigonometric identities. Cos a plus b, a x plus b. Here it will be what? This will be equal to cos x, cos y. First angle, then second angle. Then here we have this positive. You know that whenever you are taking cos, then operators will be converted into next. So here next of this, opposite of this will be negative. So cos first angle, then into, then cos second angle, then minus, then sine. Okay, sine first angle, then sine next angle. Sin x and sin y. Same here, just convert this cos x, cos y, then plus sin x, sin y. Okay. Next we have sin x plus y. Here you will see, I think, some difference. Here there is a difference. In this case, what is happening? First we are taking sine, then we are taking cos. And angle will be first angle, then second angle. Operators will be as it. Operators will be as it because of we are taking sine, that's all. So sin x first, then cos y. Plus, then cos x, cos x, then sin y. Same here, sin x, then cos y, then minus cos x, sin y. I can understand your feeling, yeah. It is looking complex. Uh, we are getting confused, are we? But we will have to understand it. Okay. You don't need to keep remember this in your mind. No, just use this trigonometric identity in your questions. Just practice more, do practice more, then you will understand it logically. Okay. This is our first question. In this question, we will apply something from this if there is a requirement. Then I am starting here over here. The sine of square. Then here we have a degree, which is in a radian. But don't worry, we know that what to do here. So sine square, then okay. Sine square pi upon 6. What is the value of what will be degree of this radian when we will convert this to radian? We know that this is nothing but 180 upon 6. So it is nothing but just 30 degrees. 30 degrees. Because 6 3s are 18. So 30. So what is the value of a sine 30? Just 1 upon 2. 1 upon 2. That's it. Here pi upon 3 is equal to I think 60 because of 3 6 are. So cos 60 is equal to 1 upon 2, isn't it? 1 upon 2, and this fraction is in a square. Next we have minus operator. 10 a square pi upon 4. Look at over here. 18 and here 4. 4. What is happening over here? 180. 4 3s are 12. 4 4 is 60. Here you can get confused. 180 upon pi. 2 to the 9 to the. And this is nothing but just 45. 90 upon 2, 45. Pi upon 4 is equal to 45 degree. So 10 45 is 1. It is in a square. Then here it is telling you that this proof that LHS is equal to RHS. Okay. So we took this LHS. With the help of this, we will bring this much minus 1 upon 2. First step is done. Let's see what should be next step. Here just to simplify this, we have substituted value of this sine pi upon 6 cos pi upon 3 tan pi upon 4. Let's remember pi upon 6 is 60. Not 60, 30. Pi upon 3 is 60. Pi upon 4 is just 45. So here this will become 1 upon 4 plus this is also 1 upon 4. This is minus 1. Now here we have fraction. 2 to the 4 and again 2 4. This 1 plus 1 and minus. What is happening over here? 2 minus 4 upon 2. So this is coming as minus 2 upon 2. But this is not our answer. Here something we are missing is that this will be 4. 2 2s are 4. Now we got our answer minus 1 upon 2. 1 upon 2. Yeah. So finally we brought this LHS is equals to RHS. We have proved. Now let's see what did we do. Here just we substituted value of this trigonometric functions. Then we simplified. After simplifying, we got this much. That's it. This was process. That is how you will solve it. Next question I am going to write. I have explained it to you. How did it come? I will tell you in separate lecture. Okay. Just here remember that yes, all these are trigonometric identities. We will apply this in our question so that we can save our time and rather than writing lengthy process, we can use our logic by using this. Next question, let me write here. Next. Look at our RHS is 3 upon 2. 3 upon 2. 2 will be as it. Sine 30 is nothing but 1 upon 2. And here we have cosec. Cosec, how much? I think it should be. It is nothing but just just 6 pi minus pi upon 6. This is what is happening. Upon 6, isn't it? And here we know that we can convert into it is nothing but cosec square. This can be written as 6 pi plus 6 plus pi upon 6 will give us 6 as it. So I think it should be also 6. So this is nothing but pi plus pi, okay? Here pi plus pi upon 6. look at over here. It will become 6 pi plus 5. Yes, this is correct. Now this is correct. So it is becoming 5 plus pi upon 6. And we have a cos square pi upon 3. Look at over. Pi upon 3 is nothing but just 60. So value of this would be how much? 1 upon 2. 1 upon 2 square. Now it will become 1 upon 4. We have this here. Pi, it is 180. So function, this trigonometric function will be as it. But what about the sine? What about the sine? It is coming in third quadrant. This is coming in third quadrant, isn't it? So in third quadrant, we know that tan cot. So that's why this operator will become minus. And it will be as it, cosec square. And here we have pi upon 6. Next we have 1 upon 4. Now we are able to, we simplified it, okay? So 2 to the 4, 1 upon 2, minus, this is minus. Cosec 60, not 60, cosec 30, 30, okay? It is a reciprocal of a sine. So sine 30 is nothing but 1 upon 2. So it is giving us a 2 raised to power 2 upon 2. 1 upon 2 minus 2 to the 4. It is giving us 2. 1 upon 2 minus 2 upon 1. We have fraction. So this 1 minus 2 to the 4. So here we are getting this much. Where is missing part? Where is the missing part? 2 1s are, okay, 2 2s are 4, but here minus 3 upon 2, brother. So hold on. This is plus. And it is in, yeah, now it is correct. It will become positive. If it is a positive, then this will, it is giving us 5 upon 2. Hold on, missing part is over here. It is 1 upon 4. Okay, this is 1 upon 4. It is a 4. Then 1 upon 4. Okay. This is becoming 1. Okay. Then here we have 2. 1 plus 2. 3 upon 2. Now this is correct answer. Missing part was over here. Now this LHS is equal to RHS. RHS came as a 3 upon 2. RHS came as a 3 upon 2. I am going to write next question. Next. It's a next. Let's solve it quickly so that we can write next question. I wrote this so that you can get clarity. Here we have this cot of pi upon 6. It is nothing but just a 30. Pi upon 6 is nothing but just a 30. So cot of 30. What is the value of it? Cot 30. I think it should be root 3, yeah. Because tan 30 is 1 upon root 3. Tan 40 is 1. Then root 3. Suppose it should be root 3. And it is an square. Now next we have cosec 5 pi. It can be written as, I think, it can be written as 5 pi upon 6. Same. This pi minus pi upon 6. Let's say, don't worry. 6 as it. Then what will happen? 6 pi and minus pi. It will give you, yeah, this is correct. So it is telling that this can be written as pi minus pi upon 6. Clear? Then we have 3. Tan 30. Tan 30 is nothing but 1 upon root 3. 1 upon root 3. Clear? We will bring 6. Now till here this is correct. And checking that is the value of tan is correct or not. Yeah, value is correct. Now look at over here. 3 3 is 9. 9 is the perfect square of 3. Here we have 180. So function will be as it. But what about operator? It is coming in second. And yeah, in second quadrant. Yeah, so this operator will be opposite because reciprocal of the sin is just to cosec. So it will be as it. Clear? Now we have theta. Next theta is pi upon 6. Then here 3 multiple. It will become 3. It is cutting to 3. So here we are getting 3 plus. What is the value of cosec pi upon 6? Pi upon 6. It is nothing but cosec 30. And this is the reciprocal of sin 30. So sin 30 is 1 upon 2. So this will give you 2. And here we are getting hold on. Hold on. This is also 1. So here you got this much. Logically. Okay. I hope you are understanding it better. Now I will write next question back after erasing it. Just have a look for few seconds, not for few minutes. Next. Now this is your question. Here we have to as it. Yeah. Here this radian is 3 pi upon 4. It can be written as, here it is a 3, so we can say 5 minus 5 upon 4. If we write like that, then will it be equal to this 3 pi upon 4? Let's check. 4, then it is 4 pi minus 5. Yeah, this is equal to that much. So that's why it can be written as sine square. Okay, this is nothing but pi minus pi upon 4. Clear? 2 cos 90 यार, cos 90. So it is nothing but just 0, 0, 0. That's right. Then 2 multiple sec 60. 3, 3 60, yeah. Sec 60. It is the reciprocal of cos. Cos 60 is what? 1 upon 2. Of course, it is giving us a 2. 2 a square. 2 multiple. Now, look at over here. We have one. First angle is 180. 180 minus. So, of course, it is coming in second quadrant. Now, in second quadrant lies two trigonometric functions with the positive operators, which are sine. So, sine is coming over here. Operators will be as it. So, sine of square, yeah, pi upon 4 plus 2 multiple, it is becoming 0. Here we have this 2 multiple 4, 8. Okay, 2 multiple here. Pi upon 4, it is nothing but just 45 degree. 1 upon root 2. Yeah, 1 upon root 2. 1 upon root 2, it is the fraction which is in a square upon it. 2 multiple 2 to the 4, 4 is the perfect square of 2. So it is becoming 1 upon 2 plus 2. Yeah, look at over here. Yeah. What is happening over here? What is the missing part? We need 10. We need a 10. So why are we writing this 8 rather than that? 2 to the 4. It is becoming 9. 9. And here cos 90. 90. One upon root 2. 2 to the 4. 2 multiple, then 2 to the 4, 4 to the 8. 2 multiple, 1 plus 8. How is it? This is not pi upon 2. It is a pi upon 4. This is a pi upon 4, okay? This is pi upon 4. If it is a pi upon 4, this will give us a 1 upon root 2. 1 upon root 2. And here this is becoming how much? 1. 1. 1. That's why this 1, 8, 1. Now this is a. So missing part was over here. When we put here 2, then answer was coming correctly. Okay. 9 was correct. Now here we put 4. So for this question, answer is 10. And if we put here 2, then answer would come as a 9. As a 9. So modify in this step. Just by if there is a requirement of modifying, then you can modify wherever you are observing by the help of this 4. Okay. Next question. Fifth. Fifth is very easy. We will use now trigonometric identity. This trigonometric identity will be used in next question just after this. here we know that this is not a familiar angle from which we can say this value of this is this much. No. So if a trigonometric function is coming like that, in that case you can use a trigonometric identity. So here it is a sum of I think mm, I think this is a sum of 30 plus 45. 30 plus 45. 30 plus 45. Am I correct? Yes. 70, 30. Yeah, this is correct. So this is the sum of 40 plus 45 plus 45 plus 30. Okay, here we can see it is nothing but sine a plus b. Okay, sine x plus y. In that case, we know that what trigonometric identity should we use. So sine x, then cos y, then plus, then cos x, then sine y, which it is equal to sine x, then cos y. Here operators will be as it because of a sine. Next we have cos x, then sine y. Clear? Cos x, then sine y. We are using this trigonometric identity. Clear? Even I think I used brother. So sine 45 is nothing but just 1 upon root 2. Then cos 30 is nothing but just root 3 upon 2. Root 3 upon 2. It is 1 upon root 2, and sine 30 is nothing but 1 upon 2. And here our work is to simplify this. That's it. Our work is to simplify this. So what is happening over here? Root 3, then here 2 under root of root 3. Next we have 1 upon 2 under root of 2. Here this both are same, that's why it will become this much. Root 3 plus 1. I think you can rationalize it. Okay, you can rationalize it. Till here this is the answer, but if you want to simplify this further, it is your choice. It is your choice. Clear? So till here this is correct. Next we have tan 15. Tan 15. Here, meaning of this answer is that this is value of this is sine. Here root 3, value of root 3 is 1.77. It is a non-terminating, and value of root 2 is nothing but all these are small numbers. It is looking that it is like a long number. No, reality is that root 3 is equal to 1.7 and root 2 is equal to 1.2. I think it should be. This is equal to value of this is sine 45 is this much. Okay. Next we have tan 15. Let me erase it. Yeah, I didn't write tan a minus b, tan a plus b. Don't worry, I will write that. So here we have tan 15. It is an unfamiliar angle. That's why we use trigonometric identity so that we can bring value of this much angle of this trigonometric function. Okay. Now here it is nothing but just difference of two angles, which are 45 minus 30. I think it should be. Let's say tan 45 minus 30. Tan 45 minus 30. So here we will use a trigonometric identity of this tan a minus b. Tan a minus b. Clear? So it is nothing but just tan operators. I think it should be as it. So it is nothing but tan A minus tan B upon 1 plus tan A into tan B. This is our next trigonometric identity. For this tan A plus B, it will become just opposite tan A plus tan B. Okay, tan B upon 1 minus tan A into tan B. There are these are two more trigonometric identity. Whenever there is a requirement of this, we will be applying. Here we are going to apply this. So here this is A and this is B. We know that tan A minus tan B. Then we have 1 plus tan into tan. So next step, tan A 45 minus tan 30. Tan 30. Tan 30 upon 1 plus tan 45 into tan 30. Clear? Now whatever you know, you can substitute value of this. So tan 40 is a 1. Okay. Tan 30, nothing, just 1 upon root 3. I think it should be 1 upon root 3. Yeah. 1 upon root 3. Then upon 1 plus tan 41, then here multiple 1 upon root 3. Clear? Here we are correct. So root 3, okay, root 3 minus 1. Then we have just this root 3, then 1, not 1 here, root 3 plus 1. This will cut to each other. We got root 3 minus 1 upon root 3 plus 1. Yeah, here one thing will come is that rationalization. This is your choice, brother. At the end, we will get to 2 minus root 3. At the end, we will get 2 minus root 3 after rationalization. So I am rationalization over here. So let me write this part over here, root 3 plus 1. Okay. This part is done. It is nothing but root 3 minus 1 upon root 3 plus 1 multiple root 3 plus 1 upon root 3. Just operators will convert itself into opposite. Root 3 plus 1. Here it is nothing but a plus b, a minus b. It will give you a square minus b square. So root 3 square minus 1 square upon a plus b, a plus b. You know that this is a plus b square. Root 3 plus 1 square. Yeah, okay. Here this is correct. This is much answer. It is becoming 3 minus 1. Then we have root 3 plus 1 plus 2 root 3. 2 root 3. It is becoming 2 upon 2 root 3 plus root 3 plus 1. This is what is happening over here. So here we didn't do this part here. Minus. Now this it is giving you root 3 minus 1 raised to power square. Then this is upon a plus b, a minus b. Here we know that it is nothing but just a square, then 1 square. This 3 will become, then we have 2 multiple but hold on, at the end 2 multiple root 3 minus 1 upon 3 minus 1. Okay, it is giving you 2 plus 2 upon root 3 upon 2. Here there is a 1 2, here is a 2 which is common in numerator, so 1 plus root 3 upon 2. 2 will cut to each other. At the end we are getting 1 plus root 3. 1 plus root 3. Where is the missing part? Missing part is over here. This minus this positive. In this case 4 minus 2 root 3. And here 2 is common. 2 minus root 3 upon 2. 2 will cut to each other. At the end we got this much. Missing part was in this. Here what did we do? Just we saw that yes, this is the difference of these two angles. Then we are able to apply this trigonometric identity. We applied this. Then we saw that we can substitute value of tan 45 can be substituted. Even value of this can be substituted. All this. Then we substituted. After substituting, we simplified this. After simplifying this, we reached over here. Then it was saying that do rationalization over it. Then we did a rationalization. After rationalization, we got 2 minus root 3. Just have a look. Next question I am going to write, which is different from this. Not a different, just trigonometric identities will be used. Trigonometric identities. 7th question. Yeah, it is complete. We have LHS and RHS. LHS and RHS. Answer is given over here. Whatever part you want to select, you can select. Either you want to select this LHS, and it is your choice here. I am going to pick up this, okay? Here, LHS. LHS, clear. Then here we are observed. We have option to apply this to trigonometric identity over here. Tan A plus B, tan A minus B. Yeah, we can see. So this tan pi upon 4 plus tan x upon 1 minus tan pi upon 4 into tan x. That is what is happening over here. Okay, till here this is correct. This is upon tan A pi upon minus tan x. This is upon 1 plus tan pi upon 4 into tan x. Clear? This is done. Now in the next step, we know that pi upon 4 is nothing but just 45. 45. So here 1 plus tan x. This will be as it because it is not giving us We don't know angle, that's why there is a value. Next, 1 as it, 1 minus tan, what is, we have again tan x, then we have upon it is 1, then we have minus, then tan x, this is upon 1 plus 1 into tan x. What is happening over here? What is happening over here? 1 plus tan x upon 1 minus tan x into 1 plus tan x upon 1 minus tan x. Clear? This is what is happening over here. We need this much. Here we know that a plus b into a minus b. It is in bracket. Here one algebraic identity we are observing over here. This 1 plus a plus b is equal to a plus b square. 1 plus tan x, it is in a square, then upon 1 minus tan x, it is in a square. Okay? Now look at over here. Both are in numerator and denominator, both are in a square. That's why we can say that this 1 plus tan x upon 1 minus tan x, this is a fraction which is in a square, and this is nothing but it is RHS. Okay? This is equal to this much, 1 plus tan square. So let's see what it is now. We proved. We have proved. Here, let's see process. Process here. Just we applied here over here. This is trigonometric identity. Here, then we substituted value of tan pi upon 4. Then after applying this value of tan upon 4, we simplified this. After simplifying this, we saw, yes, we observed one thing more, is that we have a option to apply algebraic identity, not a trigonometric identity. So here we are here trigonometric identities are applied, and after applying this we simplified this. After simplifying this we got this RHS, and question was saying proof LHS is equal to RHS. So wait, just have a look, then I will write next question. Next question is also easy. Look at over here. We will solve it quickly. Here we there is a cos pi plus x, pi plus. There are two angles. First is this angle. It is determined that function of this it would be as it. It would be as it because of first angle is 180 degree. Okay. So here, what about operator? It is coming in third quadrant, and we know that in third quadrant there are two positive of trigonometric tangents. So it is negative minus cos x. Then here we have this. It is equal to this cos x. Cos minus x is equal to cos x. So this is giving you cos x upon sine. It is in secant quadrant. This is in secant quadrant, and operators will be positive. Here 180. So that's why sine will be as it. It will not be converted. Next cos. Yeah. Over here it is 90. That's why it can be converted into another. So this will become, I think, yeah. But what about this? It is giving us minus because of it is this cos is going in secant quadrant. But in secant quadrant there are two positive trigonometric functions which are sine cosine. That's all. So what is happening over here? This minus cosec x square upon minus sine square x. This minus will cut, and we know that cos upon sine is equal to cot. Yeah, we know that. And the square will be as it. Cot square x. So finally we brought this much. Now let's see. Let's analyze process. Here we saw that here first angle is 180 degree. That's why trigonometric function will remain as it. Operators will be negative. Why? Because it is going in third quadrant. Rather than going in fourth quadrant, it is going in third quadrant. Now next here, cos minus x is equal to cos x. Here you can see. Then in the denominator we saw yes pi minus, which means in secant quadrant, and trigonometric function is the sine. That's why operator will be positive. So sine is minus. Then here cos, here 90 plus x. It is going in secant quadrant, and here we have cos. So in secant quadrant, that's why negative. Okay. Then we saw in numerator we have minus, in denominator we have minus. Both are cutting to each other, and it is equal to cot square x, and this is nothing but RHS. Clear? Can I write next question? Yeah, next question is also very easy. Just let me write. We need to get this much 1 by taking this LHS. Let's see what can we do. First of all, we need to simplify then this part. Tons. Here it is nothing but, I think, 3x upon 2. Not 3x upon 2. 3 pi. 3 pi. Let's see what is it. It should be 220. 3 multiple 180 upon 2. By 21470. Yes, 220. This is a 220. Look at one. So 220 plus 6. It is going in fourth quadrant. Where? Fourth quadrant. So this will be positive. And here it is a 220. That's why it will be converted into opposite, into another sine x. Okay. Then we have cos 2x plus x. Not a 2x, brother. It is a pi. This is pi and this is also pi. So here we have 2 pi, which is 0. Okay. 2 pi, which means 360. So operators will be as it. Cos x. Yeah, it is going in first quadrant. So that we know that all the trigonometric functions are positive in first quadrant. Now next we have this part, a quote. Then in third quadrant, positive, and here it will be tan x. Then plus we have quote. It is coming in fourth quadrant, 2 pi minus x. And we know that this will become minus because of quote should not go in fourth quadrant. Yeah, that's why. And then this will be nothing but just same because of a 2 pi. Here it is this much. What is happening over here? We know that this sine x into cos x, here tan x can be written as sine x upon cos x minus cos x upon sine x. Here we need to simplify this fraction. Sine x cos x, okay, then here sine x into cos x. Look at over here, cos x both are same, so sine square x, done. Then in this case sine, then it will become cos square x. Clear? Cos square x. Now you can see this is cut to this, and we got this much sine square x, but operator should be positive here. Operator should be positive. Let me check. It is quote, and this is coming in fourth quadrant. It was already positive. Now it is going positive. That's why this will be positive. Now this is sine a square x plus cos a square x is equal to 1. This proved. We have proved. You can analyze the process. Now next question. Yeah, we have this next trigonometric identity that is a requirement for this question. This trigonometric identity is a requirement for this. Look at over here. This is cos this angle and this angle both are same. This angle and this angle both are same. Cos A plus B, then minus cos A minus B. In that case, this identity you will use. Okay. So let's use. Here we have this minus 2, then sine A is how much? 3 upon 4, 3 pi upon 4 plus x upon 2, then minus, not minus, n2 sine 3 pi upon 4 minus x upon 2. It is not minus 2, this is minus 2. Now here we used this identity. Minus 2 as it, Let's simplify this. After simplify this, you will get 4 3 then 4x plus 4x upon 2 sine. Here what is happening over here? 4 3 pi minus 4x upon 2. Okay, minus 2 sine, it is becoming 7x upon 4, 1 upon 2, 1 upon 2 multiple sine, it is becoming minus x, wrong row. Here it should be equal to this much, minus 2 sine over here, 1 upward. Minus 2 sine 4 3 pi plus 4x upon 2 multiple sine 4 3 pi minus 4x upon 2. 3 pi upon 4 then sine x. This is for you. This is for you. You use this trigonometric identity, then simplify this. That's all.